Hello everyone, I hope you are well. And today I will show you how to calculate the standardized precipitation index SPI using NetCDF file. Maybe you have the NetCDF data, right? You want to calculate the standard precipitation index and want to draw the temporal plots like this. Okay, so in NCL has two scripts in their website. One script is to calculate the SPI and plot the temporal figures, and another script is to calculate the SPI and plot the spatial map. So for first lecture, I will show you how to calculate the SPI and draw the temporal plot, and the second lecture I will show you how to calculate the SPI using NetCDF file and draw special plots, right? So if you miss the NCL class, so you can watch my NCL lecture on my YouTube channel Jalal stream, and you will find the previous classes, so you can learn the basics of NCL. So that will be helpful for you, and there is most important lectures on YouTube. Okay, so let's get started. We'll calculate the standard precipitation index. So your data, this is the dimension SPIN. We use this function in NCL to calculate the SPI. Here you should have the data, and like this is a function. So in this function you should have a data. Data should be numeric, float, or double, right? And then n run means this is a time scale. You know very well the time scale. What is the time scale? That like 3 months, 6 months, 12 months, and 24 months, right? So then option it should be the logical. Logical means if it is false, is fed by gamma, or is 3 like Pearson type 3. Okay. Then dimension. Which dimension do you want to calculate? Is definitely the time dimension, right? Okay. So x is a data should be, the SPI only depends on precipitation. So for calculating the SPI, you need to have the monthly precipitation data. It can be float or double, but be careful, the data should be divided by 12, otherwise you can't calculate, right? So that's why the SPI dimension must be divisible by 12, like at least 30 years of monthly data. For climate change, we use at least 30 years of data. So if you have a 30 years data, then you can it's better to have calculate. So it should be divided by 12 is recommended. Then what I said before, it can be 3, 6, 12, 24, 36, 48 month time scale. Then optional is a parameter. If false, then the gamma fitting by gamma, and if it is true, it's fitting by the Pearson 2. Then dimension should be, what I say is usually the time dimension. Okay, then written below will be the SPI, is the same size and type as your data. Okay, so for you'll find this script and this online. So even I have this script here, and I will explain everything line by line. First, we need to have this data boulder precipitation. Okay, from where can you download this data? Is free, and you will find in NCL sites. So I will give you all these links underneath the video. So just check my video description. So here, if you go to the NCL website application data, so from there you can download the boulder precipitation 1897 to 2014, right? So if you watch my previous lectures about NCL, so first we need to we need to know our data. So how can we know our data? Is NCL file demo. We use this command. Okay, let me clear. Okay, so I hope you know how to get your working directory, like where you kept your data. you just, if it is Windows 10, you just use cd mount then your working directory, or it is just a Linux, then just use cd, or if you use a cguin, then after cd slash then sig drive. It is a different way. Cguin in Windows, sig drive use, if you use a Linux Ubuntu in Windows 10, use mnt mount. Okay, so I'm there, this is my working directory, and I have the script there, and even I have downloaded this data. So first I need to check my data, NCL file dump, then my data is bolder. Okay, this data. So from the data I can see my data name is okay, the data type is float and name is precip, it has a time, the unit is millimeter, so it's a the precipitation data, long name bolder precipitation. Okay, so we know that our variable name. Now come here and we already know in NCL we need to use the addfile, and R means the read. Okay, if you miss my NCL class, just watch on YouTube, and if you are new, please subscribe to my channel. Okay, then from there we define a name, year and month. Okay, from the time we'll get year and month. So we the end time, then dim size, the dimension sizes, year month. Then we checked our data if it is divided by 12. If it is not divided by 12, if, the NCL will oppose and it will print it. Okay, your data has a problem, it's not divisible by 12. What I'm saying, because if you want to calculate the SPI, you should have monthly data, like every year should have 12 months data from January to December, right? That's why it should be divided by 12. Here I use the logic like if and end if, this NCL if and if. So if end time modulus 12 not equal 0, then print end time must be divisible by 12, exit, end if, print end time. So modulus is integers only, that's not equal to. So if it is divisible by 12 is okay, if not, then print must be divisible by 12. Then we define our variable name PRC. So from the AF file, we have this file, and we already know our variable name is precip, right? Here from there, we know our variable name is precip. Okay. Even PRC field value, we define the minus 99.0, change from the default, like we have a default field value. So we want to change the default field value. So PRC field value convenience, we just use what we define. Okay. Then we want to see the print bar summary, the PRC. We want to see, and we want to print minimum and maximum value. So if you don't want to run the whole code, so you can just use the exit. Okay, save your code and run. Okay, so NCL, then file, my file name is SPI temporal. Sorry, this is my file name. So run. Now we can see the PRC. So it's a data type is float. We have the time like 1416. So it's divided by 12. Then attributes 3, we have the field value. What we define, just we define the field value minus 99,999. Okay. Okay. Then units is millimeters, long name is bolder precipitation. Then we printed out the minimum and the maximum value, right? Minimum is 0 and maximum is 461.26 millimeters. Okay. So now we know our data. Pin bar summary is very useful in NCL. See the data. Okay. And now what I said, run length. So we have the time scale. Here is a 3 months, 6 months, 12 months, 24, 36, and 48 months time scales. And then run like, okay, dim sizes, run length. Okay, these are dim sizes, like we have a 6 time scales there, right? Then option is false because we want to fit that by gamma. Now we want to create an empty array to save our SPI results. Okay, so in NCL, if you want to create an array, so you use this new function, then there is a parenthesis in new function, like we need and run the time scale and our SPI value on our time. Okay, monthly, like we'll get the monthly value. Okay, every month we have the SPI value and with this time scale. Okay, then type of use of PRC. That's mean what is the data should be. The type it should be the PRC. That's when you have a data the float. It should be the output will be the float. Then we have the missing value. Okay, print the missing value. Now we use a loop to calculate. Okay, like you don't need to calculate one by one for 3 months, 6 months, 12 months, 20 months. So if you do that, you will waste your time. So it's not good, right? Use a one by one. So you can use the loop for convenience. So here we use a loop to 0 to, the NCL is 0 base. It's like a Python, okay? It's 0 base, so it should start from 0 to n round minus 1. That's means it's just from 3-month time scale to 48-month time scales. Then we have the SPI, so these are time scale, then we will take the whole month, okay? In time, okay? Then we use this function what I said before. It has the 4th options, right? First the data, we have defined our data by PRC. Then we have the time scale. So it will go from 3 to 48 months. Then options is the false, so we want to fit by gamma. Then which dimension do you want to calculate? The first dimension, because our data only have a 1 dimension. If you have a 2 or 3 dimension, it should be the first dimension, because it should be the time dimension. Okay, if you have like a dimension, 3 dimensions like time, let, long, it should be the first dimension, time. Okay, be careful. So then undo. We have finished the calculations. Now we want to plot. Okay, so if you want to plot, like why you need to define the year, we want to make such plot. Okay, so here you can see the x-axis. X-axis is the year. So 1900, 1920, 1940, etc., etc. So we have in our file we have a year and month, but we need to make it integer year, right? For making an integer year, we need to do something here. So year is divided by 100 to make it the integer year. Then starting year from the first. Okay, starting from like 1897. Okay, then ending is 2014. So this is starting year is 0, and last year is n time minus 1. This is the last year, 2014. Okay, then n year. N year is like last year minus first year plus 1. Okay, then year and month. We know the year and month is this function. So we have the year is starting year last year, it should be integer. Then we use the year function like year month to year fraction to make our time year like this, the integer year. So we use this function just making this one. Okay. Okay. I will upload the link. And I will also upload the scripts underneath the video. So please check my video description. You'll find everything there. Okay. So now we want to save our figure as a PNG as like SPI. Okay. Give the name SPI temporal. Okay. Temporal. Okay. Temporal. Okay. Want to save as PNG. I think I don't need to describe this thing. Just watch my previous lectures. This is very basics. We have to use the resources, etc., etc. So now, why use use minus 3 and plus 3? It means the y-axis value. This is a normalization. SPI is a normalization data. So some the negative 3, negative 4, or like negative 4, 5, etc., etc., whatever. So here negative 3 to 3. This is our length. We define this. Okay. Okay. The reference line 0, 0. This means like we want to create the reference line here 0. Okay. For this one, line 0. Then dash pattern true, thickness 1, etc. Now we want to plot. Okay. So we want to create an array for n run because we have 3 months, 6 months, 12, 24, 36, and 48 month time scales. Like we have a total 6 figures, right? That's why now we are creating an array to save our 6 figures together, right? That means that this is the idea. Like in NCL, this is called the panel plots, right? In MATLAB, it calls subplot. Even in NCL, even in Python is subplot, right? Like we have a 6 figures, we want to keep 1, okay? These are what we want to make a panel plot, like 3, 6, 12, 24, 36, and 48 months time scales. So here, that's why we're creating an array. And for line colors, we have a 6, like black, red, blue, green, brown, magenta. You can give the line colors as you wish. So we have a 6 figures. So here we gave the 6 colors. Even you can give only black colors. Whatever you want is fine. Now we want to use another loop to create 6 figures. Okay, 0 to n run 1. So it should be from 3 month time scales to 48 months time scales. Then with the line colors, you use this, and that's mean from the line colors. Okay, like we have a 6 and we have a 6 time scale. Okay, then the central string means we want to write like this. Run is equal like runtime, like time scale 3, 6. Okay, run 1, 12. So that's why is run is equal run length. Run length we know is here 3, 6, 12, 24, 36, and 48. Okay. Now plot n, we want to create 6 plots. So we use the GSM, CSM, XY because they're the X and Y plots. We use a WKS, that's when we want to save our figure as PNG. Then X, we use a year, Y fraction, what I said before. We want to use the integer year. Then we have the data SPI. So n is our time length, is the time scale. Then we are taking the whole, the time. Then resources, okay. Now in NCL, we have to use the resource panel. What I said is capital P is a panel plot. Okay, it should be true. That's when modify the panel plot. So you can give the main title, or you can maximize is true. Then we need to use this function GS and panel. Right, we want to plot 6 figures together. So PNG, then PLT. Here is the 6 plots. Then this is a matrix. How do you want to show your figures? Okay, 3 into 2, that's mean 3 rows, 2 columns. That's mean 3 into 2, 6 figures together. Right? You have the 3 row and 2 columns. Okay, that's up to you. Then resource P. Okay, let's have run this code. Okay, now run this code. This is our output. We got the same figure as NCL website gave. Okay, so this is how we can calculate SPI using NetCDF file in NCL and draw temporal plots. If you are very new here, please subscribe to my channel and watch these NCL lectures on YouTube, so you will get everything. Thank you so much, and I will show you how to draw the special figure using NetCDF file and calculate the SPI in NCL in the next lecture. Bye bye.